Now we talk about continuous conditional distribution. So we are just going to copy the discrete case. So f of x given y, this is equal to, you have the joint density here of x and y divided by just the density function of random variable y. And similarly for the cumulative distribution function, probability of x is less than equal to c, some number c, given that random variable y takes on value small y, is you integrate this function here, right here, with respect to x. So notice that if you just had this, then this definition is again very easy. This would have just been this. So now you have just modified it, you have just conditioned it on y. So notice the similarity between this definition and this definition. So we just have conditioned it on another variable y. So let us see this with an example so everything becomes clear. So say you're given this joint density function of x and y, where x and y lie in the interval 0 to infinity. So that is the random variable capital X takes on numbers between 0 to infinity. So again notice that this x is a function, this is a random variable, it's a function. This small x is the values which this function takes. So this function capital X is taking values in the interval from 0 to infinity. Similarly with random variable y, it is taking values between 0 and infinity. So outside this interval it is 0. So notice that we generally consider interval from minus infinity to infinity, just like here. But here in this case, it is 0 outside 0 to infinity, so we just consider the interval 0 to infinity. So first step is you copy down this definition right here. So this definition you copy down right here. So focus on the denominator. So denominator is the marginal. It is the marginal density. And you know the marginal density formula is, you integrate out all the values of x. You go from minus infinity to infinity, take the joint density function, and then you integrate with respect to x. And that's what we have done here. Instead of minus infinity we have 0 because the working interval is 0 to infinity. So that is what you put in here. F of xy is right here. Integrate with respect to dx, you will get exponential of minus y. Now you focus back on this formula. Now again this expression comes from right here, and this denominator we have just computed here. Plug it in, so you get the conditional distribution. So this is conditional. So this is conditional density, you can say, or mass function.